Hello my dear friend, welcome. Till now we have studied the equations of motion in our chapter in physics, that is motion. We understood that how a body basically travels on a straight line, what different types of motion it can perform. We studied about uniform motion, we studied about uniformly accelerated motion, non-uniformly accelerated motion, non-uniform motion and various other categories. Now we will study a different type of motion. Till now we are considering that the object is traveling on a straight line, okay, that the object is always traveling on a straight line, it is not taking any left or right or not going in any other direction, it is traveling in a single direction, okay. But there is a very special case that we will discuss right now, that is the case of uniform circular motion. We will understand the case of uniform circular motion. Now it's a very interesting case. You can see the terms that we are using here is uniform. Okay, what is uniform? We studied that uniform means constant. Okay, then the next term is circular. So what can you understand by this uniform circular motion? Or if I say, what can you understand by the term circular motion? I will say that when a body travels in a circular path, the motion is said to be circular motion. The motion that the object will perceive would be known as the circular motion when it is traveling along a circle. Okay, along a circle, you know what is a circle? Circle is a path, okay, which is it's a what we can say the path of a point which is always at a particular distance from a given point. Okay, so if a body travels on a circular path, that motion will be known as the circular motion. Now if I say uniform circular motion, so uniform circular motion can be defined as when a body travels along a circle, okay, with constant speed, the motion is said to be uniform circular motion. The motion will be said to be the uniform circular motion when an object travels along a circle with a constant speed. When its speed is constant, that motion will be known as uniform circular motion. Now you may wonder that why I am writing here the term speed. Why not velocity? Why didn't I write velocity here? The reason is velocity can not be constant when an object travels along a circular path. Okay, so let me write the point here. Let's write it here. Velocity is always changing along a circular path. Okay, the velocity will always going to change when an object travels on a circular path. You know this because See, velocity is what? It is the combination of speed and direction. Even though we can see that speed is constant along the circular path, an object can travel. For example, you can run along a circular path with a constant speed, but your direction will always going to change, and due to this ever changing what we can say the phenomena of direction, we will say that velocity can never be constant when an object travels along a circular path. Okay. Now, to understand this concept, that what I am saying, is it true? Okay. To understand this concept, let's take a very interesting example. For example, let us say this is a running track. Okay. Let's say ABCD is a running track. So what will happen? If I say an athlete is running around the circular this ABCD track, he will run like this. For example, let's say he started running from point A, he ran in to this point B, then he ran this and then this and then this. So the athlete is running from A to B, B to C, C to D and D to A. Now what you can observe is, when the athlete was running along the path A to B, he was running on along a constant direction, along a single direction, that is in this direction. But as soon as it reaches the point B, the athlete has to change its direction, okay, from this direction to this direction. So what I can observe here is that along this path ABCD, the athlete is changing its direction 4 times. Okay, the athlete is changing its direction at point A, B, C and D. So we can see along this path the athlete changes its direction on A, B, C and D. So at 4 different points the athlete is changing its direction. Okay. Now let's assume that this track is what? It's a quadrilateral, it's a 4-point figure. Okay. At 4 vertices, we can see A, B, C, D are 4 vertices of this rectangular or quadrilateral figure. Now consider a different kind of track which has more vertices. Let us say a hexagon. If I draw a hexagon like this, okay, this is A, B, C, D, E and F. So this is a hexagon. You can see this hexagon has 6 points or 6 vertices, I will say. Let us assume that athlete starts running from this point A. Now if the athlete starts running from point A, he will run along the straight line till the point B, and after B it has to change the direction to move to point C, and then he will change the direction to move to point D, then E, then F, then again A, and the circle will go on and the process will continuously go on. So what we can see in this figure, which has 6 vertices, the athlete has to change its direction at 6 different points. Okay. So here athlete will change its direction at A, B, C, D, E and F. The direction will change. Okay, at these 6 different points the athlete has to change its direction. So what we can see, what is the difference between this and this figure? You can see here we have 4 vertices, so athlete has to change its direction 4 times. But in this figure this has 6 vertices. So here the direction change will happen 6 times. Okay. Now consider a further more different figure which has more vertices compared to this or this. Let's say an octagon. If I draw an octagon, let's say this is an octagon. Okay. So its vertices are A, B, C, D, E, F and G. Okay, sorry, H, till H. So this is an octagon, and let's say this is an athlete track on which the athlete is going to run, and on this track you will observe that if the athlete starts running from this point A, he will run till point B, then from point B to C he has to change his direction, then again change in direction, then again the same thing will happen. and we can see here on this track the direction of athlete is changing 1, 2, 3, 4, 5, 6, 7 and 8 times. Okay, so the direction change will happen. Direction change at A, B, C, D, E, F, G and H. At this 8 different points, the direction of athlete will going to change. Now consider if I take a figure which has 10 vertices, let's say decagon, or if I consider any figure which has increasing number of vertices, 12 vertices, 15 vertices, 20, 100, 200, 1 lakh or infinite. Okay, so if I am going to increase the vertices of this figure, what will happen? The number of change in directions, okay, the direction change that will going to happen will increase. Okay, so as soon as the number of vertices increase in the figures, the direction of athlete will going to change. Okay, there will be an increase in the direction change. Similarly, if I increase this vertices, what will happen? If I assume or if I increase this vertices till the point of infinity, okay, here we have 8 vertices. If the vertices are increased to infinity, the figure will be known as a circle. Okay, so here we can see more vertices means more direction change. Okay, more vertices means more direction change. So if the number of vertices is increased to infinity or infinite, then this will give rise to a figure which will be known as a circle. Okay, so what is a circle? It's basically a plane figure with infinite vertices. Okay, as soon as I start increasing the number of vertices, okay, what will happen? The direction change will increase. Okay, that's why I will say that as soon as I reach the infinity, okay, means a figure, a plane figure which has infinite vertices, that figure will be known as a circle. So can you imagine what will going to happen if an athlete travels along a circle? If an athlete travels along the circle like this, okay, like this, so at every point of time the direction of athlete is different. So I will say when an athlete travels along a circle, its direction will change, direction of motion will change at every step. Okay, the direction of motion of the athlete will change at every step. So you can imagine, for example, this is a point, an athlete starts traveling from this point, the direction at this point would be like this. If it goes to this point, it will be like this. It will go to this point, it will be like this. At this point, it will be like this, and so on. Okay. So what I am basically saying, that if a person, if a body travels along a circular path, what will happen? Its direction will change at every moment. Okay, its direction of motion will going to change at every moment. Okay, so that's why here we can see that the change in direction will happen infinite number of times, and we will say that since there is change in direction continuously, so velocity can never be constant, because it can run with the constant speed, but the direction will change, so velocity can never go constant. That's why we call in uniform circular motion, the body is running along a circular path with constant speed, not the velocity. Okay, please mind it, not the velocity, with the constant speed. So here we can see that how basically the circular motion is defined. Now you can see that in this circular motion what is happening? the velocity is getting changed at every instant. So we will say the velocity will change at every instant. The velocity will change at every instant. Okay, so velocity is always changing along a circular path. The reason for this statement is due to change in direction. Due to change in direction, this particular phenomena will going to happen. Okay, so first you note the basic introduction to circular motion, then we will understand some examples and we will analyze this circular motion a little more. Okay, not to the extent of calculus or class 11, or not to the extent which the Newton basically explained. Okay, because that you will study in class 11th when you study calculus or mathematics related to this. Okay, so for at this point of time, just understand the basic the definition of circular motion. So first you note this and then we will discuss it further. Okay, so as we defined that circular motion, okay, circular motion means an object traveling along a circular path, and uniform circular motion means the object traveling along a circular path with constant speed. Okay, so if it is object traveling with constant speed but changing direction at every step. Okay, at every moment the direction of the object is changing. So we can see that the velocity is not constant. So here we will write, since velocity is not constant, the uniform circular motion is also said to be. Now what we can say this uniform circular motion? As you can see, the velocity is not constant, and related to velocity we define a term, a very interesting quantity, that is acceleration. So we said that what is acceleration? It is rate of change of velocity. Okay, it is basically the change in velocity happening in a particular time interval. So we will say that here, since the velocity is changing, so definitely there is acceleration. So that's why we say that since the velocity is not constant, so we will say uniform circular motion is also said to be accelerated motion. Okay. Now why here the acceleration is arising? It's because there is a change in direction. Since the direction is changing, we will say there is an acceleration, even though we know that speed is constant. Okay, till now what we studied is the acceleration means increasing velocity, that is speed is increasing, or the deceleration means decreasing velocity or decreasing speed. We considered that case. The reason is that till now we understood only those examples, we have only taken those examples which includes straight line motion, that object was traveling on a straight line. But if the object is traveling along a circular path, its speed can be constant but direction can change. That's why the acceleration will arise. Okay. Now how the acceleration will arise, you will understand that concept when you go to class 11th. There we have a concept of vectors, and then you will understand why the acceleration will arise in uniform circular motion. Even though we are calling it as uniform motion, uniform circular motion, but the other name is accelerated motion. So try to compare the two things, that when we saying that this is uniform motion, Till now we understood that uniform motion means there is no change in velocity, but in uniform circular motion, if we talk about, there is a change in velocity. Okay, so that's why it's a very special case of circular. The circular motion is a very special case in this chapter, motion. Okay, now as we said that it's accelerated motion. See, you may wonder that why the object is continuously traveling along a circular path. How the object is traveling along a circular path? Even though we can see when we draw a circular path like this, we draw a circular path like this, and let's say a body starts traveling from this point A, the direction of velocity, okay, till in the previous example we have drawn the diagram that how the direction of velocity will look like. So I will say that if the object starts traveling from this point A, its direction of velocity would be like this. Okay, if it is moving along the circular path, at every point its direction will going to change like this. So how can we write this particular thing technically? You can see, if I consider these directions, I can see that the direction of motion of the object is along the tangent to the circular path. Here I will write direction of motion is always along the tangent to the circular path. Okay, please understand this term tangent. Tangent means a line which is touching a circle at a single point. Okay, you understood this in your geometry in mathematics. The tangent is, it's a line which touches a circle at a single point. That line will be known as a tangent. So at every point the direction of motion of the object will be tangent to that point. Okay, tangent to the circle at that particular point. So that's why we can see this is the point. Okay, let's say the object starts traveling along this path, it is traveling in this direction. If I consider the motion of this object at this point B, I can see its direction of motion is along this tangent that I can draw at this point B. Okay, so you may wonder that since the direction of velocity is along this path, so object should go in this direction, should go in this direction, or should go in this direction. But still the object is traveling along the circular path. So why it is possible that object is traveling along the circular path? It is possible due to force. Okay, there is some force which is binding the object to travel along the circular path. That force, you will study that force in detail in the chapter laws of motion. Okay, the force and laws of motion. But for this particular example or for this particular topic, I will tell you the name of the motion. We will say the object is traveling along the circular path. The object is traveling along the circular path due to a force which binds it to the circle or along the circle. Okay, which binds it along the circle. The name the name of that force is centripetal force. Okay, centripetal force is a force which binds the object along a circular path. Okay, for this consider a thread. Okay, very good example, a very interesting example. For example, if I take a thread and if I tie a stone at one of the end of the thread, and if I start moving the thread like this, okay, by holding the other end, if I start moving it like this, what will happen? You will find that the stone will continuously move along a circular path and you will feel a force in your hand. The reason you are feeling the force is the direction of motion of the stone is along the tangent to the circle, but since the stone is tied to the thread, okay, since the stone is tied to the thread is keeping the stone along this circular path. Okay, for example, let's say this is a stone, and if I tie it like this, okay, if I tie it and hold the other end of this thread and start moving it like this, the stone will move along this circular path. Let's say this is the point. The stone will move along this circular path, and at every point the direction of motion of the stone will be tangent to this circle. Okay, but the stone is not leaving its path. The stone is not leaving its circular path. How? Why it is possible? It's possible because of this thread. The thread is keeping the stone along this circular path by applying a force. Okay, the force that this thread will apply on the stone will be known as this centripetal force. Okay, I will say that this thread is applying centripetal force on this stone so that it can keep revolving or keep moving along this circular path. This centripetal force is always applied towards the center of this circular motion. So I will say it is always applied towards the center of circular path. It is always applied towards the center of the circular path. Okay. Now, why it is applied towards the center, you will understand in class 11. That topic is beyond our scope. There is a new force which is known as tension, which is arising in this thread, and that tension is applying a force on the stone to keep it or to move it to the center of this circle. Okay, but since the stone has some velocity or it has some speed, so it is moving along the circular path. It's not falling near the center, or it's not falling on the circle. Okay, or the center of this circle. Now observe the situation. If you hold the end of the thread and if you start moving it like this, the stone will move along the circular path. And if you leave the thread, okay, if you leave the thread from your hand, you will find the stone will go tangentially. Okay, the stone will go like this. For example, if you are moving the thread like this, you are holding it from here. If you leave this thread from, or you leave this end, what will happen? The stone will shoot in this direction. You can perform this experiment, but it's it may cause some issue. Okay, so it's better not to perform this. Just try to imagine the situation. The stone will move along the thread. The reason is, if you leave this thread, what will happen? The centripetal force will go away. The thread will not be able to apply the centripetal force. That's why the stone will move tangentially along the tangential path, okay, along the tangent to this circle. This example can be seen for the moon. Okay, moon is revolving around the earth. So why the moon is revolving around the earth? It's because, for example, consider this as moon, okay, and consider this as, let us say, earth. So the velocity of the moon is always at the tangent to the circle of this motion, but still the moon is continuously revolving around the earth. Why it is not moving away from its path, or why it is not falling on the earth? The reason is, the earth is applying a force called the centripetal force towards its center. Okay, the earth is applying a force on this motion towards its center, and it's the earth, this force, this centripetal force applied by the earth is changing the direction of this moon every time. Okay, or you may consider any artificial satellite. For the artificial satellite also we have the same concept. The satellites move along the circle, okay, around the earth. They move on a circular path. They move with a constant velocity, or constant speed. their velocity will always be tangent to the circle or tangent to the path or the circular path on which they are traveling, and they are traveling along this path. The reason is Earth is applying centripetal force, okay. Earth is trying to push those satellites towards its center. But you may wonder that Earth is applying force on moon, but still the moon is not falling on the Earth. So why it is happening? It is happening because the Earth applies only that much force which is required to change the velocity of moon. It do not have that much energy or that much force, okay, that much power to apply the force or to bring the moon towards its center. It can only change the direction of moon, but it cannot bring this moon towards the center, okay, or at the center of the Earth. So this is why the moon is moving along the Earth, okay, or the artificial satellites are moving along the Earth. Or you may wonder the motion of the Earth. Earth is moving along the sun. So why it is not falling on the sun, or why it is not going away from the sun? Because the force that is applied by the sun is sufficient to keep the Earth revolving or to keep the Earth moving around its or moving in a circular orbit, okay. Now you can see if an object is moving along this circular path, we know a parameter in the circle that is known as radius, okay. Radius is, let's say, r. Let us say the speed of the object with which it is moving is v, okay. V means the speed of the object. So you can see, let's say, let the object complete one circle in t seconds, okay. Let's say the object completes one circle in t seconds. So we know a formula called speed is equals to distance upon time. So how much distance this object is traveling if it is moving along the circle? The object is traveling or object is tracing this circular path. So I will say the distance traveled by object to complete one circle, okay, or one complete revolution, it has to travel the distance equal to the circumference of the circle, okay. Circumference of the circle, what is the circumference? It is 2 pi r. So circumference C, it is 2 pi r. So here I can write the formula that speed is equals to distance, that is 2 pi r upon time t. Time t represents the time required to complete one circle, okay. 2 pi r represents the distance travelled to complete one circle, and v represents the velocity or the speed with which the object is travelling along the circle. So this is a formula that can be used in circular motion. There are various other types of velocity also available in the circular motion, that is the angular velocity, okay. That is, angular velocity traces the angle with which the object is travelling, how much angle the object is swiping along this circle, okay. But that is again beyond our scope, it is not the point of discussion. So this is all about the circular motion. You just need to understand what is circular motion, the examples of circular motion. The examples are the stone and thread, the example is Earth and moon, okay, Earth and artificial satellites, Earth and let's say sun, okay, Earth and sun, or along the athlete circular track, okay. So these are some very important examples. Remember this formula, remember the definition, remember the point that we have written here, that is, this is also the accelerated motion, and the examples. This is sufficient, it's more than enough for any exam which you are targeting at this level, okay. So this is all about the circular motion. We completed here our chapter motion, and now we will discuss some of the numerical problems to understand the application of equations of motion, okay. Okay, so you can note this and then we will continue.